Okay, so last official talk of the day by Nea Erlich.
Nea, yeah.
Nea, and you're from Ben-Gurion University.
I'm from Ben-Gurion University.
And I'm going to learn a lot. That's all I can say.
Thanks so much. Can you hear me okay? Okay. Sean, that was marvelous and terrifying. But thank you. I've got a sabbatical coming up, so I made notes. Thank you so much. And my talk has to do with boredom, actually. And it also has to do with Alma's amazing talk about stopping for a second. And I have to say that I just love the variety of the talks here. So let's begin. I'm an art historian, and I deal with contemporary art, and I research animation. And my point today is to show you that animation is so much more than you may think it is. Etymologically, animation, I'm going to start with animation, then I'm going to talk about slow animation and de-animation. I'm going to talk about glitch, and I'm going to talk about animation and AI, so just so you know where we are as we progress. So what is animation? Animation is actually a lot of things. Etymologically, it comes from Latin, animare, and it has two meanings. One is theological, which is endowing with life, of course, and one is more secular, which is movement. Now, most of you probably have Disney in mind. I will mention Disney, but I want you to think of movement and what animation is today. The technologies of animation really change what animation is. And if you notice what I'm doing, I'm moving my cursor. Now, there are lots of ways to define animation. The way I define animation is movement only visible on screen. So once we have technologies like motion capture, we have a real body moving, those movements are captured, and then an image is placed upon those movements. What we see right now, we see my movements being translated in real time on screen. And we live with this all the time. Like, think of your GPS system, right? We're constantly seeing our real physical world through our window, but then we have our screen, so we see our physical world and our actions translated in real time onto this tiny screen, and we're actually navigating both. So animation has actually become GUI, graphic user interface. It's the visualization of code, and that changes everything. And I'm going to put a pin in that, and I'm going to come back to that later. But I'm going to start with going way back to this, okay? Because when we think of animation, we of course think of Muybridge. Edward Muybridge, one of the pioneers of photography, he started with motion photography, where he used lots of incredibly sensitive cameras that could take very, very fast pictures, basically faster than the human eye can perceive, which was then able to divide motion into frames, into still frames, which would allow us kind of insight into what would otherwise remain unavailable to us. And of course, showing these frames in a certain pace creates this illusion of moment. So the whole idea of movies, we typically shoot movies at 24 frames per second, and I know most of you know this. But the idea is that research says that we can actually perceive somewhere between 30 and 60. And when you think of different animation these days, or animation in games, the pace is just unbelievable, okay? I try to show my kids, force them to watch older films just so that they're able to watch slower pace on screen. But the idea is that in order to create realistic animation, there's a certain pace that we have to maintain. So Ollie Johnston and Frank Thomas were animators at Disney, and in 1982 they wrote the 12 Principles of Animation, one of which is this one, which is slow in and slow out. And the idea is, and this is where it connects with Alma and what she was saying, the idea is that every action, it begins with an acceleration, and then it ends with a deceleration of movement, which means that if we're animating a movement, we need a lot of frames in the beginning and at the end of each movement. That's in order to create something realistic.
Slow in and slow out. This principle refers to how all the movements begin slowly build momentum, and then finish slowly, basically easing in and easing out of the action. You can achieve believable lifelike movements using this principle, as you can see in the example. The box with and without the ease, the latter has a very drab linear motion as compared to the previous one. As action starts, we have more drawings near the starting pose, one or two in the middle, and more drawings near the next pose. Slow ins and slow outs soften the action, making it more lifelike.
Okay. But then I'm not interested in realistic animation. I deal with animated documentary and what it is about seeing things that don't look real, do we believe, what it does to us, all about experimental animation. So my question is, what if we're not attempting realism? Let's look at completely different effects and what animation can do. And this is where I want to talk about slow animation, which in a way is de-animating. If animation is giving life, then de-animation is creating stillness, or almost stillness, or forcing us into stillness, or playing, compressing, or changing what our sense of time is. I'm assuming you've all seen Hitchcock Psycho. I see some nods here. I don't know how many of you have seen Douglas Gordon's 1993 version of Hitchcock Psycho. This is an art installation, an appropriation of Hitchcock's 1960 thriller. But what Douglas Gordon does is he slows down the film so that instead of 24 frames per second, it's 2 frames per second. And that means that the film is now 24 hours long instead of 109 minutes. Now, even the most dedicated of viewers is unlikely to ever see more than a few seconds of the original film, but if we're never bored, which is what we just said, I'm going to show you a whole minute. Breathe deeply. I see your eyes closing, and it's the end of the day, so I'm going to stop it here. But it's a fascinating experiment because a lot of the reactions to this was the idea, first of all, that it's completely hostile to audiences, okay? And it's completely pretentious, and we can talk a lot about it in contemporary art and elitism. But it also says several other things. First of all, it plays with your sense of memory, because if you've seen the original, you're automatically trying to piece together the pieces, you're trying to figure out the narrative. Even though the soundtrack is turned off in this example, some people can almost hear Hitchcock's choice of soundtrack. So it's amazing about this presence and absence simultaneously. But it also does something else, and this is part of slow cinema. Slow cinema is this idea that it doesn't bother with narrative, but it invites a spectator in, okay? So instead of thinking about the narrative, you're feeling it, okay? Because you have no choice, you're bored, right? It's like you're thrown into something, and there's suddenly time to contemplate, you're aware of the people around you, okay? I could suddenly see you shifting in your seats. And it's almost like reading a book, right? It allows you to pour yourself into these images rather than being more passive because you're interested or there's a pace going on. So there's a slowness that gives you more of a central position. The other thing that was said a lot about Douglas Gordon's work was the idea that it was a very important time in technology studies. This is early 90s. People had the VHS at home. This was the beginning of where people could watch movies at home. So you weren't reliant on the pace of the cinema. You could start deciding when to stop, when to continue, when to fast forward, when to rewind. So there's a play with technology that before that wasn't possible. And this leads me to Rosa Menkman, to Glitch Studies Manifesto. I don't know how many of you know this work, but glitch, of course, is a mistake, right? okay? And we often associate mistakes with something bad, something negative. Rosa Menkman, however, discusses the potential of glitch, okay? So if we're talking about a blackout, right, the minute that the electricity stops or the minute that our phone stops working, we're suddenly so aware of the technology that otherwise we take for granted. So first of all, it makes us notice the apparatus. First things first, okay? Secondly, by not taking it for granted, we can start noticing it, messing with it. So it's the potential of glitch is using technology wrongly, okay? A mistake is no longer negative, it suddenly becomes a beautiful sense of potential, okay? So what if whoever created technology told us we should use it this way and that? I can now start using it differently. And this is where I want to go and discuss AI. So animation and AI may seem like completely counterintuitive things. First of all, obviously, if animation is endowing with life, then the connection between animation as artificial life and artificial intelligence, that makes sense. The other two characteristics of animation are, first of all, a series of images, but a series of images that incorporate metamorphosis, right? There's a slow movement between images when we think of animation. So this was the most basic example of what animation is that I could find, right? And I want to show you that actually using this idea of what animation is, which is a series of images and slow changes in between, is actually very important to the visuality of AI, both in its input and its output. And I'll show you what I mean. So basically, as we all know, in order to train AI, we use these huge data sets of images, right? So that the AI systems can actually slowly understand the patterns, understand the connections between these images. Now, understanding these patterns and connections is quite parallel to finding the similarity, finding the connections between similar images in animation. So this is a very strange example, but if I wanted to train an AI system to recognize a flea, it would probably look something like this. This is an example of AI output, okay, where the base image is a city in Germany, but then different styles copied from different artists are then implemented on the first image. So what we see is a slow metamorphosis from one image or one style to another. Now often when we encounter AI, all we see is maybe the first image and the last image, okay? But once we break it down, the parallel to animation can become quite obvious. And I'm really interested in this idea because when we think of the algorithms that we're surrounded by, especially algorithms that are used in the industry, they are completely black boxed, okay? Not only because most of us don't understand the algorithms necessarily, but just capitalism, right? Like no one's gonna give you the algorithm. And for that reason, a lot of these algorithms that deal with imagery, the images are under-researched, okay? They're just part of the algorithm. But once we use these visual culture theories and ideas on algorithms, it's almost like a glimpse into these black boxes. I want to show you, I'm going to end by bringing all these things together. This idea that by using animation theory and the idea of glitch, we have a glimpse into the black boxing of AI. So I talked about animation, I talked about the different frames, I talked about how to create realistic animation. But if we don't create realistic animation, but we create slow animation, so less frames, so that the move from one frame to the other is not seamless, but actually very jumpy, that creates that sense of glitch. And when we talk about glitches in AI, it's actually a glimpse into what are these series that the AI system is trained on. Which images are missing within these data sets? Because if they weren't missing, the animation would be seamless. So I'm going to show you an artwork called the ZZ Project. The ZZ Project started in 2019, it's ongoing. It's a collection of works by Jake Elwes that explore the intersection between artificial intelligence and drag performance. So drag challenges gender and it explores otherness, while AI is often mystified as a concept and a tool, and it's complicit in reproducing social bias. So Zizi combines these themes through a deep fake, synthesized drag identity created using machine learning. I'll show you about 2 minutes and then I'll conclude. So remember when I talked about this, right? Remember when I talked about animation as a visualization of code? We've got this great example here, okay? This is a visualization of code of AI. Just like my cursor, which is a translation of real bodies, the movement of real bodies, but then look differently, this artwork is also based on the movement of real drag performers, but then AI-generated images, AI-generated drag performers take their place. So let me explain. The Zizi project has several stages. The first was to mine the database. So they were adding more images of London-based drag performers into the data sets that define AI input and output. And this was done in order to, and I quote Elwes here, introduce some queerness and otherness into AI systems, which is sorely needed at a time when the biases are being hard-coded into these systems, leading to algorithmic social injustice. And the second stage was to create a data set of images of the existing drag performers from all these angles, which were then converted into stick figures post-detection. The neural network's job is then to create new fake images based on these stick figures. And once the neural networks got very good at turning these stick figures into bodies, they were then fed into new movement, which would be converted into stick figures and then created an output of realistic deep fake of the original body. But of course, what becomes interesting are these glitchy moments when the process breaks down, when we see the limitations of the deepfake process at work because there aren't enough images of drag performers within the data sets. So because we don't have enough of these frames, if you will, that is what creates these jumps. That is what allows us, exposes the gaps in the information that we're building our technology on. So I'm going to conclude there, and I hope that at least slightly I've made you think differently of what animation is and how it can be used to think about our contemporary moment. Thank you very much.
More of observation rather than a question. I notice on myself whenever I'm watching animated projects and so on YouTube, and I watch a lot, there is also this kind of sense of we need to animate a still figure too, so that we know that the frames are going forward even if nothing happens. And then once that action is not done, if I'm watching some really low budget student wanna do something and the figure is just still, I check if the video is still rolling. So it's so deeply embedded in us to see that even in stillness there is some motion. It's really incredible to see that in the perspective of what you were talking about. So thank you very much for that.
We're all tired, it's fine. It's fine.
There's another question. So we can consider glitches as an indication that there's inequality, or like, is that what you're saying?
The idea,
so
yeah.
There are biases, etc., where information is missing.
Well, the glitch is always what wasn't expected, right? So that glitch is literally that hole, right? To see what's not working, why isn't it working? What are the people who created this technology? What were they overlooking that created this glitch? How can this be fixed? Should it be fixed? How can it be fixed, right? So I think mistakes have such potential, right? To kind of give us a glimpse into what otherwise is kind of disguised or, yeah, made invisible, kept invisible.
I was just going to comment on at the beginning. You talked about the slow in and the slow out at the beginning. So we talked earlier today about the minimum jerk trajectories where you have the velocity slow at the beginning and end. So it basically looked like they were just suggesting you should do a minimum jerk, which is biological motion follows these
animation. Yeah. No, that's why I said it was such a variety and so many crossovers that it was quite exciting. Yeah.
Yeah, and just it was very interesting to me the notion of this when there's something unexpected in what you call the glitches. I mean, it really pulls out the attention. And also when we're looking at movement, or when someone's producing a movement, and we see these unexpected things, they catch our attention and they catch
completely, completely. So don't aim for seamlessness. Make mistakes, I guess. Okay. Thank you so much.
Yeah, so we now have some time actually left, so we can take a nice 15-minute break and then gather for some small groups, see what brainstorming we can come up with. Right?
Yeah, at 4:15. At 4:15, and just if you're leaving now or hopefully later at the end of the day, just please leave the name tags next to the entrance. Yeah.